Extreme travel is inherently risky. The space probes Voyager 1 and Voyager May 2 have recently encountered such an obstacle, whose temperature exceeded that of fires on Earth dozens of times. Deadly currents and whirlpools on rivers, avalanches of ice on mountains. But what if a wall of fire more than 500 million kilometers in size gets in the way? 45 years have passed since the beginning of the voyages from Cape Canaveral. During that time, the probes traveled to 4 far-off planets, took striking images, and carried out hundreds of scientific investigations. Later, the probes ventured beyond the solar system, where they encountered a real red-hot hell. This was not the only exciting and occasionally terrifying adventure along the way. However, Voyager 1 recently began sending data that had scientists perplexed. What did scientists learn about the Voyager's adventures? How has the spaceship survived the terrifying wall of fire thus far, and why will the probe's entire voyage through interstellar space be accompanied by the soft patter of rain has been a constant feature of nearly 50 years' worth of probe equipment that has survived to travel beyond our solar system, enduring the terrifying radiation of space travel. Low temperatures with dust as sharp as needles may seem unreal, but it was made possible by the space probe's exceptional degree of protection, which includes plastic jackets and multi-layer thermal insulation heat shields. Individual elements of their defense line are quite simple. For example, shortly before launch, strips of kitchen aluminum foil were glued to some of the cables as a protection against radiation, and it worked perfectly. The amount of work and people put into the development and implementation of the project is about 11,000 years. This is equivalent to a third of the effort expended to build the Great Pyramid of Giza. When the probes were launched into space, they headed for Jupiter. Saturn, Neptune, and Uranus. Their voyages took many extraordinary images. In addition to the iconic pale blue dot and volcanic eruption on Jupiter's satellite Io, there are less known but stunning images. Check out this TED of the Earth and the Moon. The image was taken as Voyager 1 headed toward Jupiter. In this image, both our planet and its satellite look like two crescents moving somewhere in the same direction, and here you can see the edge of Titan's disk. Saturn's largest satellite was captured by Voyager 2. Nonetheless, why is it available in 2 colors? Simply put, the enigmatic haze appears blue when viewed from a few hundred miles above the atmospheric surface. The atmosphere itself has an orange appearance and is primarily made up of nitrogen, along with traces of methane, carbon, and maybe hydrogen molecules. This is said to have been the state of the Earth's atmosphere before life began to form. Music. The probes made surprising discoveries when they reached the edge of the solar system and then the edge of the heliosphere, which was filled with solar wind. They entered the helioport region, where the pressure of the solar wind and the interstellar plasma is equalized. Prior to this mysterious location, scientists had only studied it through simulations. After flying around the planet, the probes turned off their cameras and some other devices to save energy, but other devices were still able to conduct research and send data back to Earth without much difficulty. Astronomers had predicted that the galaxy's magnetic field near the heliopause would be tilted toward the solar magnetic field, but the probes found no change in the magnetic field's direction and a particle density 10 times higher than in a solar wind. Flows of solar and interstellar particles collide in that region at unimaginable speeds, causing them to glow and form a wall of fire, a phenomenon known as the wall of fire. It's unclear whether the fire is actually burning there or if it is a familiar type, but it is evident that the plasma at the heliopause outer boundary is between 30,000 and 50,000 Kelvin. Although it seemed impossible to pass through this area unharmed, the probes were successful. The plasma proved to be extremely thin, much thinner than the air on Earth's surface, and as a result, it did not heat the probes to dangerously high temperatures. Studying the red-hot wall is very important for scientists. After all, it is the heliopause that is the solar system's last line of defense against dangerous cosmic rays and interstellar dust. The heliosphere blocks approximately 70% of the deadly radiation coming from deep space. Without it, life on Earth would have been impossible, and the wall of fire that Voyages discovered most likely plays an important role here as well, but we still don't know whether astronauts will be able to overcome it during interstellar missions in the future. According to astrophysicists at Boston University, it largely depends on the shape of the heliosphere. Is there some safe loophole in it for Starship crew scientists used to believe that the heliospheric bubble was shaped like a comet's tail, but new research suggests that it might have the shape of a donut or a croissant. If so, it'll have gaps in it which astronomers will have to find. As the probes entered into stellar space, they recorded different sounds. We wouldn't have heard them, but the instruments picked up the noise and transmitted it to Earth. At first, scientists couldn't determine their source. Later, they've come to the conclusion that it's the sound of gas in interstellar space, and there's much more of it than previously thought. In the meantime, spaceships continue to transmit valuable data to Earth, although it takes about 20 hours for the signal to reach us. Besides, not everything ran smoothly. Voyager 1 has had problems on more than one occasion. Back in April 1978, Voyager 1's main radio receiver malfunctioned. Since then, it's been operating on a backup receiver. Recently, something strange started to happen. Voyager 1's telemetry began sending absurd data back to Earth. Telemetry is the measurement and collection of information to provide to the operator or user. The probe continued to keep its antenna pointed at Earth during the mission. Specialists investigated the situation and identified the source of incorrect telemetry. It turned out that the information was transmitted through a computer that stopped working many years ago. It was corrupting the data, so a command was sent to switch to the right computer. After that, everything went back to normal, but the cause of the malfunction is still unknown. In addition, the Voyager's power sources are getting cooled and depleted, and they're no longer able to fully maintain the temperature of the equipment. However, NASA engineers claim that the spacecraft still has enough fuel to keep its instruments running until at least 2025. The Voyagers will eventually lose contact with us, but they will carry on traveling into interstellar space, largely through voids. Only in about 30,000 years will the Voyagers pass through the Earth cloud, a shell of comets and icy debris orbiting the solar system, and only in about 40,000 years will Voyager 1 be closer to the star Gliese 445, 17.6 light-years from Earth, than to our Sun. By that time, Voyager 2 will pass 1.7 light-years from the red dwarf star Ross 248 of the constellation Andromeda. Looking even further into the future, in about 230 million years the solar system and Voyagers will make a complete revolution around the Milky Way. It's impossible to predict what will happen to Earth by then, but can the probe survive that long in interstellar space? Scientists believe that it mostly depends on the amount of dust in the Milky Way. This dust flies at several miles per second like a nano-meteor shower. The dust particles slowly erode the shell of the probes, and even a dust particle the size of 1,000th of a millimeter leaves its microscopic mark on the ship upon impact. Scientists have repeatedly modeled the trajectories of the probe, their encounters with dust clouds, and possible damage. Calculations by Nick Oberg of the Captain Astronomical Institute in the Netherlands have shown that the Voyager golden records have a chance of surviving the longest because of how valuable information they carry about Earth for a possible alien encounter. These records have great protection. Underneath the gold cover of the gold-plated discs is an aluminum coating, and underneath that is a copper base. The half-life of plutonium-238 in the Voyager nuclear reactor is 87.7 years, and in a small area of the coating of uranium-238 it is 4.5 billion years. We can hardly imagine such a distant future, but scientists have painted us a rough picture. At that time, the Milky Way should already have collided with the Andromeda galaxy. The spiral shape of the Milky Way would be severely deformed and possibly completely destroyed, and the collision could eject the probes from the new monster galaxy. The chance of this event is estimated at 1 in 5. In this case, the main threat to the golden records in intergalactic space would be cosmic rays and strange hot gas molecules. The fate of the Voyagers will depend on the same dust if they stay within the unified galaxy. If the probes enter a dense cloud of dust, they have a very high chance of collapsing, but star formation at that point may virtually cease. The Voyagers will drift through a completely unrecognizable galaxy, free of main sequence stars. In space, there will essentially only be black holes and the remnants of stars, white dwarfs, and neutron stars. There will be total darkness everywhere, with the exception of sporadic flashes of supernovae. The Voyagers will be able to marvel for trillions of years while other probes explore the outer solar system and interstellar space. NASA developed the interstellar probe concept, which is intended to be outfitted with a variety of cutting-edge and dependable technologies. The probe will be able to investigate the solar wind in great detail and its application to spacecraft navigation.